Welcome to Spring LIB.
So we know that energy of a photon is equal to Planck constant times frequency of the photon, and that can also be written as hc over lambda, where c is the speed of light and lambda is wavelength of the photon. Now in the first part, we can use the principle of conservation of energy. So the energy lost by the incident photon will be converted into kinetic energy of the electron. So E will be equal to E dash, which is energy of the scattered photon plus energy of the electron, kinetic energy of the electron. So this is the initial total energy, which is just the energy of the original photon, and this is the energy after scattering, where we have the contributions from the scattering energy of the photon and the kinetic energy of the electron. So let's use this expression of E over here. So we have hc over lambda for E, and then hc over lambda dash for E dash plus Ke. So now we can solve this equation for Ke, the kinetic energy of the electron. So that is equal to hc times 1 over lambda minus 1 over lambda dash. So we substitute the values now. So this is h, then we have c, speed of light, then we have, okay, let me just write that over here. So then we have 1 over lambda. Make sure you put this in units of meters so that all your units are consistent, and lambda dash is 0.1132 times 10 to the power minus 9 meters. So now we solve this equation and find Ke to be 5.105 times 10 to the power minus 17 joules. And if you want this energy in units of electron volts, so we know that 1 electron volt is charge of electron, joules. So we can divide this conversion factor over here and find Ke to be over. So I'm just doing the conversion, and we find Ke in units of electron volts. So that's the kinetic energy, and that's the first part. Now, in order to find the velocity or the speed of the electron, we know that kinetic energy is half times mass, here mass of the electron, times speed square. So speed will be equal to root over of 2ke over m, and mass of an electron is 9.11 times 10 to the power minus 31 kg. So we substitute these two values over here and find speed of the electron to be 1.0586 times 10 to the power 7 meter per second. So that's the first part. Now in the second part of the problem, we need to find the wavelength of the photon. So we already found kinetic energy of the electron that comes from the energy of the original photon. So, and this energy gets converted into a photon. So we can write this energy to be energy of a photon, because By conservation of energy, the kinetic energy of an electron gets converted into energy of a photon, and that is equal to hc over lambda. So now we can solve this equation for lambda. So lambda comes out to be hc over energy of the photon, and that is kinetic energy of the electron. Now substituting the values for these three, we get lambda to be 3.89 times 10 to the power minus 9 meter, and this is equal to 3.89 nanometers. Thank you.